Picture this, you're lounging by the pool on a scorching summer day. As you take a refreshing dip into the cool water, you can't help but wonder, did this H2O come from outer space? It might sound like a far-fetched idea, but scientists are actually on the case, trying to figure out if Earth's water crashed into our planet from space, or if it's been with us since the beginning. So let's dive into this watery mystery and see what they've discovered so far. The search for extraterrestrial water is a bit like searching for a needle in a haystack, especially considering how vast space truly is. But our cosmic detective work has led us to an intriguing conclusion. Earth is the only rocky planet in our solar system that we know of with a significant amount of water on its surface. Now you might be thinking, hold on, what about Mars? Well, while Mars does have some water, it's mostly frozen and found in its polar ice caps and underground. Here on Earth, about 71% of our planet's surface is covered in liquid water, and it's this unique feature that makes Earth a bit of an oddball in our planetary neighborhood. So where did all this water come from? To answer this age-old question, astronomers and geologists have come up with two main hypotheses, each with its own set of supporters. The first hypothesis suggests that water has been with Earth since the very beginning, stored in the planet's minerals from the early days of its formation. The second hypothesis proposes that Earth's water arrived from somewhere else, delivered by cosmic visitors like comets, asteroids, or meteorites. It's like a cosmic game of Clue, and scientists are on the hunt for the most likely culprit. But before we delve into these theories, let's take a closer look at Earth's watery makeup. Our planet's water is not just found on the surface. It's also present deep within the Earth's mantle, the layer of hot, dense rock between the Earth's core and crust. In fact, scientists estimate that there's about 3 times more water in the Earth's mantle than in all of Earth's oceans combined. This discovery, made possible by analyzing the seismic waves that travel through the Earth's interior, suggests that water has a much deeper connection to our planet than we previously thought. The first hypothesis proposes that Earth's water originated from materials that coalesced and formed the Earth in its early stages. These materials, primarily a hot molten rock known as magma, contained significant amounts of hydrogen and oxygen. As the Earth cooled, these elements combined to form water, which became part of the planet's mineral structure. This means that Earth's water is not just on the surface or in the mantle, it's actually locked inside the very minerals that make up our planet's rocky exterior. But wait, you might ask, if Earth's water has been here from the start, where did it come from in the first place? Well, the answer could lie in the composition of the materials that formed Earth. Scientists believe that these materials were rich in hydrogen and oxygen, which may have originated from the giant molecular clouds that gave birth to our solar system. These clouds, primarily made of hydrogen and helium, also contain significant amounts of oxygen, along with trace amounts of other elements like nitrogen, carbon, neon, and magnesium. Through a series of complex reactions and chemical processes, these elements interacted to form the building blocks of Earth and, importantly, its water. Now you might be wondering, if this hypothesis is correct, why hasn't Earth lost its water over billions of years? After all, space is a pretty harsh environment, and Earth has been bombarded by all sorts of cosmic radiation. Well, the key to understanding how Earth managed to retain its water lies in the behavior of hydrogen and oxygen in the planet's mantle. These elements tend to bond with other elements, such as silicon and magnesium, to form minerals such as olivine and pyroxene. These minerals, in turn, become part of the Earth's mantle, helping to stabilize and preserve Earth's water content. However, sometimes these minerals undergo metamorphism due to high temperatures and pressures, releasing water back into the mantle. This process, known as dehydroxylation, plays a crucial role in transporting water from the Earth's surface to its interior. And it happens naturally through volcanic activity, which releases water vapor into the atmosphere. Over time, this process has helped maintain Earth's water balance, ensuring that our planet has retained its precious supply of water for billions of years. However, not everyone is convinced that this hypothesis paints the complete picture. Critics argue that the amount of water released through volcanic activity would be insufficient to account for all the water on Earth. Additionally, the stability of water in the Earth's mantle depends on various factors such as temperature and pressure, which may have fluctuated significantly over billions of years. These challenges have led scientists to explore alternative explanations for the presence of water on Earth, such as the delivery of water by external sources like comets, asteroids, or meteorites. This brings us to the second hypothesis, which proposes that Earth's water arrived from interstellar space. Proponents of this theory suggest that icy bodies like comets and meteorites could have collided with the young Earth, delivering their water content to our planet. In fact, scientists believe that many of these collisions may have occurred during a period of intense bombardment known as the Late Heavy Bombardment, which took place about 4 billion years ago. During this period, the inner solar system experienced a surge in collisions between planets and other objects, leading to the formation of new craters and the redistribution of materials. Some researchers even speculate that one of these collisions may have been the cataclysmic event that led to the formation of the Moon. But what's the evidence for this extraterrestrial water delivery? Well, scientists have analyzed the isotopic composition of water from various sources, including meteorites and comets. Isotopes are variations of atoms that have the same number of protons but different numbers of neutrons, which can provide valuable insights into the origin and evolution of materials in space. By comparing the isotopic ratios of water on Earth to those found in extraterrestrial objects, scientists can better understand how our planet's water came to be. Interestingly, some studies have shown that certain types of meteorites known as carbonaceous chondrites contain water with a similar isotopic signature to Earth's water. This similarity suggests that these meteorites, which are rich in carbon and other organic compounds, could have played a significant role in delivering water to our planet. But it's not just about the isotopic composition. Scientists have also examined the chemical properties of water in space to see if it matches the water we find on Earth. For example, researchers have studied the presence of deuterium, a form of hydrogen with an extra neutron in its nucleus, in both extraterrestrial and terrestrial water samples. By comparing the ratios of deuterium to regular hydrogen, scientists can gain insight into the conditions under which the water formed. One study published in Nature in 2016 reported that the deuterium to hydrogen ratio of water from several comets is similar to that of Earth's water, providing further support for the hypothesis that comets may have contributed to Earth's water supply. However, despite these tantalizing clues, there are still challenges and uncertainties associated with the extraterrestrial hypothesis. Critics argue that the total amount of water delivered by comets and meteorites may not be sufficient to account for all the water on Earth. Additionally, it's not entirely clear how water from space would have survived the intense heat generated by collisions with Earth's atmosphere. Despite these challenges, scientists are continuing to explore the possibility that external sources like comets and asteroids played a role in delivering Earth's water. One promising avenue of research involves studying the water content of objects in the Kuiper Belt, a region of icy bodies beyond the orbit of Neptune. By analyzing the composition of Kuiper Belt objects, scientists hope to better understand the conditions in the early solar system and determine whether these objects could have contributed to Earth's water supply. As the search for extraterrestrial water continues, scientists are also exploring a surprising new potential source, the Sun. A study published in the journal Physical Chemistry, Chemical Physics in 2023 suggests that water on Earth may have originated from ionized hydrogen and oxygen in the Sun's atmosphere. According to this theory, solar flares and coronal mass ejections, which are massive bursts of plasma and magnetic field from the Sun, could have delivered water-forming molecules to Earth's surface. While this hypothesis is still in its early stages, it offers a fascinating new perspective on the complex processes that may have led to the formation of Earth's water. The quest to understand the origins of Earth's water is a journey that takes us to the very beginnings of our solar system and challenges us to explore the most fundamental aspects of our planet's composition. Whether the water came from the depths of Earth's mantle or arrived from distant corners of space, one thing is clear: Earth's water is a vital part of our planet's story. So next time you take a sip of water, remember that you're partaking in a cosmic legacy that has been billions of years in the making.